Hey guys, my name is Mauricio Crispim, and in today's video we're going to talk about psychrometrics applied to air conditioning. Psychrometrics is the science that studies the physical and thermal properties of the air-vapor-water mixture, and that is why it is very important in different segments of the industry. Now in air conditioning it is simply fundamental, so that you can understand the thermal process involved. And in our video we will use the psychrometric chart. The psychrometric chart is the tool that will allow us to carry out these studies and understand this air conditioning process. And so once again, I ask you, if you like the video, give it a like, subscribe to the channel, share it with colleagues who we will continue to bring you quality content. So let's look at our psychrometric chart. The psychrometric chart is a fundamental graphic tool when we are talking about air conditioning. It is the psychrometric chart that will show us the amount of energy necessary for our conditioning, the amount of energy necessary for us to transform the air into the desired conditioning conditions. So the psychrometric chart informs several properties of humid air. The air we breathe has water vapor in suspension. The composition of atmospheric air, many people think that it is basically oxygen, and that is not the case. The atmospheric air that we breathe is approximately 78% nitrogen, around 20% oxygen, a small amount of other gases and water vapor in suspension. And water vapor, humid air, is fundamental to our health. Repeating this once again. So what data do we have here in the psychrometric chart? We have the dry bubo temperature. The dry bubo temperature is what we measure with a common thermometer. Wet bubo temperature. The wet bubo temperature is a temperature that we measure using a thermometer, whose bulb will be wrapped in cotton, for example, moist. And when passing flow through this thermometer, we will have here, it would be the thermometer bulb. We have a thermometer bulb, and in this bulb, we wrap cotton soaked in water. When passing air flow through this cotton, part of this water will evaporate, and the thermometer will indicate the wet bulb temperature, the temperature at which the water is being evaporated in this airflow. We sometimes say that the dry bulb temperature is the temperature that we measure, and the wet bulb temperature is the temperature that we feel. When we sweat, exercise, and sweat to balance our body temperature, our body feels the temperature of our sweat evaporating, which would be the wet bulb temperature. Tá bom? The wet bulb temperature is indicative of the amount of moisture present in the air. For example, the wet bulb temperature is almost always lower than the dry bulb temperature. Here we have humidity curves. So if I take a temperature here of 20 degrees, if the wet bulb temperature is also 20 degrees, it means that my humidity is at 100%. Se a minha temperatura, tá? If my humidity is 30%, I'll go here and find a wet bulb temperature of 15 degrees, okay? Let's erase these lines here. So another important point here, another important property that we were able to capture in our psychrometric chart.
Métrica, tá? Então,
The relative humidity curves, which refers to a ratio of how many percent of water vapor can still evaporate into my air.
tá?
The absolute humidity on this vertical axis, the absolute humidity in grams per kilogram of air.
Tá?
The specific volume of my air, then, the lower the temperature, the less dense. Specific volume is the opposite of density, so the higher the temperature, the greater my specific volume, and the lower my air density. Not forgetting to mention the psychrometric chart, it depends on atmospheric pressure.
Érica,
So this chart we are using is a chart for atmospheric pressure at sea level.
tá?
Enthalpy in kilojoule per kilogram. Enthalpy in kilojoule per kilogram. So enthalpy refers to the internal energy of the air, and it is one of the most important points on the psychrometric chart, because it is what will inform the amount of energy that I will spend to take the air from one state to another.
Tá?
And basically these are the points present in the psychrometric chart. Okay? So let's look at a practical example. We're going to do an example here where we're going to have outside air and return air. The outside air will renew our air.
Tá?
So I will have here, I considered a simple example. I will have external air with a dry bulb temperature of 35 degrees Celsius and a relative humidity of 50%. So what can we do with these two data? I can extract from my psychrometric chart that I can get the temperature of the humid bubble, the enthalpy of the external air, the absolute humidity, the specific volume. The specific volume.
Específico. Tá? Ah,
And let's do the following. Our total flow of our equipment will be 3,400 m3-hour, and the renewal will be 10%. So the flow rate of the outside air will be 340 m3-hour. The return flow rate will consequently be 90%, which will be 3,060 cubic meters hour. Okay? Then let's mark this point here of the outside air on my psychrometric chart, so 35 degrees. I'm here. I'm going to draw a line until I find the 50% curve, and I mark my point here. I'm going to erase this line, and now I mark my point here. So what is my wet bulb temperature? My wet bulb temperature is here, so it is about 26, 27, 28, 29, 26 degrees Celsius. My wet bubo temperature.
vinte.
26 degrees Celsius.
Qual a minha entalpia nesse.
Okay, my enthalpy at this point is 80.5 kilojoules per kilo. So my enthalpy is 80.5 kilojoules per kilo.
quilojoules por quilo.
What is my absolute humidity? What is my absolute humidity?
Puta.
I follow my absolute humidity here, and I will find approximately 17.5 grams of water vapor per cubic meter.
(17,5 por metro cúbico.
And what is my specific volume? My specific volume, I'm here on this purple axis.
Tá?
So, my specific volume, I bring a more or less parallel line here, 89, 89.5, 89, 895, 897, about 0.897 cubic meters per kilogram. And also, then, since I have this, I can find my mass flow rate.
Tá.
My mass flow rate will be m mass. It will be 340 cubic meters per hour divided by the mass, will be 340 m3 per hour, divided by 0.897 m3 per kilogram. Cut here, it will be in kilograms per hour. My flow rate in kilograms per hour will be external air. It will be 340,897 divide 379 kilograms per hour. Per hour. Now let's go for our return air. So my return air. My environment will be 22 degrees. So, my dry bulb temperature is 22 degrees. My temperature is also my relative humidity is 50%. So let's look for other properties there. So we will have the wet bulb temperature. We will have the enthalpy of my return. Let's have the specific volume of my return. So, I come here 22 degrees until I find my 50% curve, which is here. So my point is this one here, 22 degrees, 50%. What is my dry bulb temperature, wet bulb temperature? I come here, it will give about 15.5 degrees Celsius, equal to my enthalpy. It will give here 41, 42, 43, 43.5. So it is 15.5 and 43.5, 15.5 and 43.5.
(3,5)
15.5 degrees Celsius, 43.5 kilojoule per kilogram. 2.5 kilojoule per kilo. Now what is my specific volume? So let's draw a parallel line here, which gave 0.85. It was also here in the middle, 0.45, 0.847, also 0.847, 0.847 cubic meters per kilogram. Cubic per kilogram. Okay, I can now also calculate my mass flow rate. So my return mass flow rate will be equal to 3060 divided by 0.847. So my return mass flow rate, 3060.847 divide, that gives 3612 kilograms per hour. 3612 kilograms per hour. So I now have 2 points, which is my internal air that is returning, and the other is my external air. They will be mixed, so I will make a line connecting these 2 points. My line didn't look good, let's remove it here. I'm not going to remove it here, and my mix between these 2 flows will be somewhere along this line here. The 2 flows will mix without there being an exchange of energy. So, according to the law of conservation of energy, we will state that the weighted sum of the 2 energies present in this air, in the mass of this air, will be maintained. So, how are we going to do this? I will take
Tá?
I will now calculate the enthalpy of my mixture. The enthalpy of my mixture is going to be the enthalpy of my return air times the mass of the return air. So it's going to be the return enthalpy, which is 80.5 times 379.
79.
8,980.5 times 389, which is my mass flow rate, times 379, which is my mass flow rate, plus my air and my return air, which is 43.5 times the maximum flow rate of the return air, which is 43.5 times 3,612, divided by my total flow rate, which is 379 plus 3,612. '79 plus 3,612. This total mastic flow rate is 3,612, 379, plus the total maximum flow rate is 3,991. So let's go. So the enthalpy of my mixture will be 80.5 thousand 379 times 43,53,612 times more divided by 3,991. It will be 47 kilojoule per kilogram. So let's go back to our psychrometric chart.
Métrica.
Going back to our psychrometric chart, 47. I come here. I'm going to get 47 on my psychrometric chart. So I'm 45, 46, 47. You see that it is very close here on the part of. So she comes to be here. She comes to be here. And here then will be the point of my mixing between the return air and the external air.
Tá? Que vai.
It will be this air from the mixture that will enter our coil. It's okay? So, what are the conditions of my air in my mixture? Let's see what its temperature is. The temperature of the dry air will be 21, 22, 23, 23.6 degrees. So let's go. The temperature of the wet air in the mixture? My wet bubble temperature of the mixture will be 15, 16, 16.7 degrees Celsius. What is my relative humidity?
Viva.
It's a straight line which takes off from the 50% curve, so it will be more or less 51%. 51%.
51%. Então,
So now we have the characteristics of the air that will enter our coil, but now we will have to cool this air and also dehumidify this air.
tá? Então,
So we realized that our project, our thermal load, told me that we needed to provide a flow of 3,400 M3 total hour, inflation temperature of 12 dig, with Bubuma temperature and relative humidity of 90%.
tá?
This is the inflation to combat my thermal load, so my inflation dry bulb temperature will be 12 degrees, my relative humidity will be 90%. So let's now mark this point. Now mark this point, I chose another color here, red, so 12 degrees. My dry bulb temperature is 11 degrees. and my specific enthalpy will give 31.5 kilojoules per kilo. So my supply air, which is at 12 degrees Celsius, with a relative humidity of 90%, will have a wet bulb temperature and an enthalpy in the middle of the supply, only returning there of around 31.5.
Cinco. 31.
31.5 kilojoules per kilogram. 31.5 kilojoules per kilogram.
Então,
So what energy is needed to make this transformation? What do I have to do with my air?
eu tenho que levar deste ponto até este ponto. Tá? Então, o que que isso significa?
I have to leave this point here with 47 kilojoules and cool it to have an energy of 31.5, so I have to get here. My mixture is 47, so my energy change has to be 47 kilojoules per kilo minus 31.5 kilojoules per kilogram.
Delta
dH equals 47 minus 31.5 in kilojoules per kilo times my maximum flow rate, which is 3,991 kilos per hour.
três nove nove quilos por hora.
Cut kilo by kilo, so my delta H will be equal to 4731.5 minus 3,991 times it will be equivalent to 60. I have to remove 61,860.5 kilojoules per hour from my air. How do I transform that to TR? We divide by 12,660.
1660.
So, my DH is equal to 61,860 divided by 12,660, so my delta H is 4.9 TRs, which is consistent with my flow rate.
Tá?
The psychometric process, to take from this point to this point, here is what was spent in sensible heat, and here is what was spent in latent heat. What made the latent heat? I removed moisture from the air, so my air was about 9.5 grams per cubic meter per kilogram, and now he's at about 8 grams per kilogram of air.
Tá?
So here, this energy here was latent heat. And here the sensible heat is how much energy I spend to reduce the air temperature.
Tá?
So what I presented to you is the psychrometric process of standard air conditioning. So you can also have heating. You can have it when you aim for dehumidification after the coil you do reheating. Often it is also necessary to humidify after the coil is sprayed with water vapor and so on. So you have several psychrometric processes in this mixture of atmospheric air, and the psychrometric chart can help you have a good understanding of each of them.
Tá?
There is software today that helps a lot with this, but theory is not the enemy of practice. So if you can do it using a psychrometric chart, I even suggest that you print a psychrometric chart and do it on paper, even with a square and a ruler to do your math, then that's fine. That's what we had to present for today. So that's what we had to show you today. I hope you liked the content, and if you like it, I ask here, give it a like, subscribe to the channel, share it with your colleagues, that we will continue to bring you quality content. Until the next video.